All right. I will begin with a word of prayer. Dear Father, we thank you for this day. Thank you again for these students. Just ask that you'd help us to understand a little bit more about complex analysis today, Lord. In your name I pray. Amen. All right, so this is exercise 18 from section 5 of the third edition of Churchill's complex analysis. This is probably a collectible at this point. I mean, the third edition of Churchill. This is really something. I mean, got this from Sprano's office. May not have permission at the moment. Don't tell him. So here's the thing that we're told. Let's see if we can work it out together. P of z equals to a naught plus a1z plus an z to the n. All right, is a polynomial of degree n greater than 1, he says, then there exists r greater than 0 such that the size of p of z, the absolute value of p of z, modulus if you like, is greater than the modulus of a sub n times the modulus of z to the n divided by 2. For all z greater than r. Okay, so if we were allowed to assume that this is true on faith, your problem would already be done. So the problem I gave you was to bound the polynomial, a given polynomial, right? And I think I even had the a sub n essentially equal to 1, didn't I? Right. So that says that you could choose m equal to a half then, if we trust what's written here, in that will work out for year 1. But it's not at all obvious what the r is, right? So in some sense, it only, I mean, even if this were given to be true, it's only half solving our problem, right? Now let's see if we can follow his hint, because he gives a substantial hint here, otherwise I wouldn't even care. The hint is this. He says, observe for some positive number r, each of the numbers, see if we can follow this, for some r greater than 0, each of the numbers modulus of a sub n minus 1 divided by z, modulus of a sub n minus 2 divided by z, z squared, modulus of a sub n minus 3 divided by z cubed, and so forth and so on, modulus of a sub 1 divided by z to the n minus 1, and finally modulus of a sub naught divided by z to the power n. These can all be made less than the modulus of a sub n divided by 2n when modulus of z is greater than or equal to r. And then there's more past this. Let's see if we can, I mean, I'll talk about what to do with this, but first let's see if we can verify this much. Like, can you see how would we do that? So the claim is, for appropriately chosen r, we can make everything in that list less than a n divided by 2n. Maybe we should just focus on one of them to start with, right? I'm trying to show that a bunch of things are true at once, right? Let's focus our attention just on one thing. How about a sub n minus 1 over z. We'd like to say that that's less than a sub n over 2n, allegedly, for appropriate choice of z. So what would this, let's see, so we could rewrite that as the modulus of a sub n minus 1 is less than 1 over 2n modulus of a sub n times modulus of z. What should I make? What condition do I need on z? I mean, the a sub n's are given, right? Like a sub n minus 1. We're stuck with those. We can't do anything to those, right? Oh, maybe I should just... Perhaps I should just solve this for z, right? Or, I'm fine. Modulus of a sub n minus 1 over modulus of a sub n, right, times 2n. Has to be less than n is fixed here, right? I mean, I'm not thinking about like a limit as n goes to infinity or anything like that. What if the modulus of let's see. I was thinking, what if the modulus of z? Thinking like modulus of z is greater than 2. Then I'd have like a 2 to the n, and I've got a 2 to the n minus 1, and so forth. Is that a good starting point? I mean, is 2 to the n? I mean, 2 to the n is larger than 2n, isn't it? Two n. 2 to the n. I'm not sure where these... I'm not sure what this actually looks like. I know that it's got at most... Maybe there's 2 intersection points, yeah. But certainly 2 to the n wins eventually. 2 to the 1. So this is 2 to the 1 equals 2 times 1, yeah? Oh, fair enough. What's the other intersection point? No, I'm interested. 2 to the n equal. Oh, 2? Oh, I'm an idiot. Okay, so this point is 2 comma 4. Okay. All right. So for n, suppose n is greater than or equal to 2 for the sake of not thinking about n equals to 1. I bet we can give a proof for n equals to 1 separately. That's easier anyway. So if I let my r equal to the max of 2 to the n, that seems like a start, because then I have, then if I have modulus of z greater than or equal to r, that implies what? That modulus of z is greater than or equal to 2 to the n, which implies that if I have a sub k over z to the, what do I want? A sub k over z to the n minus k, that's less than what? Yeah.
Why are you saying n greater than or equal to 2? Because at 1 and 2, in both spots it's equal. So like if you want it strictly greater than, would it have to be greater than or equal to 3? So like if n is 1 or n is 2, 2 to the n and 2n are equal in both cases.
There you go. But I have a suspicion once the fog clears from why this is true, we're going to find out that that's an unnecessary restriction anyway. So I'm not super worried about that. So this is, let's see, to make the denominator smaller makes the fraction larger. So this is ak over 2 to the n, right? But this is less than ak over what? We have, what's the relation between 2 to the n versus 2n? It's greater than, right? So replacing 2 to the n with 2 times n is making that fraction larger. So the inequality is legitimate, right? That's almost what I want, right? Because I just got, see, now I have anything in that list, right? Anything in that list that I'll underline in blue here momentarily is what? It's smaller than the coefficient which appears, right, divided by 2 to the n. But I want to say that we can bound it by, the leading coefficient divided by 2 to the n. Now this, for you guys it's 1. But even so, even for your problem, you can't say that this is less than 1 over 2 to the n, right? I mean, it's not, that's not, I mean, what I'm trying to say is maybe we need to play some other game here besides the one we're already playing. Right? Or maybe I'm just I'm not an analyst, and I will fail to see things obvious right in front of my face when it comes to inequality. So don't have no fear to point out an easier way if you see it. All right, so I mean, on the other hand, if you look at the set of values, right, the moduli of the coefficients, right, if you look at these things, a sub naught, a sub 1, a sub 2, a sub n, right? If you look at that set, that's just a set of real numbers. They're given, they're fixed finite numbers, right? So we can definitely say that these are less than or equal to like some number, some positive number times a sub n, right? These are going to be less than or equal to k times the modulus of a sub n for some k positive. Agree? Oh, no. I'm assuming that a sub n is, well, maybe I am. Just don't give up on that. I am assuming that a sub n is non-zero. That is true. Now you're saying it's assuming a sub n is, well, I didn't say that k had to be has to be, I mean, if a sub n is the biggest, then I can just put k equal to 1. But if a sub n happened to be smaller than something that was bigger, I could multiply it by a number big enough to make it bigger.
You can find a k where
Right. And in fact, this would not be a big deal for an actual given polynomial even, right? Can I somehow incorporate that k? See, because then if I could do that, this would be less than or equal to, k times the modulus of a sub n divided by 2n, right? I may be off the edge of the universe for the projector. Yep. Oh, and here's the, sorry, people not here. So sorry. I'm never a very good cameraman. Now I think that I'm actually content with that. I don't even really care about fixing that. I think we could go through and just put a k here. I mean, that's a fixed I mean, I can just keep r equal to the max of 2n, right? That doesn't seem right. It seems like I must be missing something, because
I think you can, like you did with this model, we have a sub k over z to the n minus k.
uh-huh.
Can we generalize that same idea but go back to the first approach on the left where we have a sub n minus 1 over z?
Oh, wait a minute, by the way. Why would I have 2 to the n there? Hold on a second. Hold on a second. You guys shouldn't buy that. Come on, guys. I mean, hold that thought, Jonathan. This should be what? Two to the n minus k, right? Because it's the n minus k. It's not n power there. I'm assuming that z is larger than r, which is larger than 2 to the n. Maybe I just need 2 there, huh? I'm an idiot. Look, I want 2 here, right? I want 2 here, so that gives me that z to the k, I mean, whatever power you like, z to the j is greater than or equal to 2 to the power j. That's what I should write there, right? Now, so then this is, by my thinking, less than or equal to k. Ooh, most unfortunate choice of letter. We need to pick a different letter for that k. This must be something, we need to relabel this something other than the k we're using as an index, right? This is bad. What you guys make whatever you want that to be. What do you guys want it to be? Big L? All right, big L. All right. Try to move along here. So then, this is less than or equal to L times a sub n, right? Divided by 2 to the n minus k. I would like to replace that with less than, a to the n over 2n if I want to follow Churchill's hint. I mean, this is Churchill's claim, is that you can choose an R such that that list of blue underlined things is less than the red one. Yeah? Does that make sense? I mean, is it possible, can we say something more about, does that, I don't know. What is 2 to the n minus k is what? That is, I mean, one way we could write that is 2 to the n over 2 to the k, right? And that is greater than 2n over 2 to the k, yeah. Oh, move the, okay, so moving up here, we have a to the k over modulus of z to the n minus k less than, if you, so you're saying L, move the 2 to the top, 2 to the k to the top, modulus of a sub n divided by 2 to the n. Now that is less than 2 to the k times L modulus of a sub n divided by 2 to the n, right? 2n. Maybe, you know what I think I need to do, guys? I think I need to use one of my copies of Z to take care of the other junk here, all right? So here's the idea. Split off one of the Z's and use your control of Z to put to death the 2 to the k and the L term. 2 to the k and L, these are a finite list of things. K is not unbounded. K goes between 0 and n. And L is a fixed number. And I can get control of that if I use one of the Z's here. See, rather than using all of them to make the 2 to the n, what I'm going to do is I'm going to re-gear this just a little bit. I'm going to say, okay, so that's modulus of z times the modulus of z to the n minus k minus 1, right? And then that will be less than, L times 2 to the k plus 1 over modulus of z, right? And then modulus of a sub n divided by 2n. Aha! Now we're in business. See, because I can do more than just assume that z is beyond 2, the disk of radius 2. I can do more than that. I can also play games with this. I want that to be what? I want that to be less than 1. See, because if that is less than 1, then I get the inequality a sub n divided by 2n. Agree? So what does it take to make the thing that I just circled to be less than 1? Right. L to 2 to the k plus 1 divided by modulus of z less than 1. So you said that means that modulus of z has to be greater than L times 2 to the k plus 1, right? But this is not just one thing. K is, right, this actually descends to what? We got k equals to 0, which is what? 2L. And then k equals 1 gives us what? 4L, right? 8L, all the way out to what? L times what? 2 to the n plus 1 times L, right? Right, so you just max of 2 and also, you know, L times 2 to the k plus 1 such that k equals to 0, 1, 2, da 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 n. And so if we make that our R, then we will have that all of the things underlined in blue are less than the modulus of a sub n divided by 2n. If we are not anywhere near done, because all we have at the moment is an inequality that we can use, right? Now, he gives us more, though. That's not the end of the hint. All right? If that was the end of the hint, I'd just say forget about it, right? I mean, like, just pack up and go home. Is everyone with me on this much? Okay. I'm happy. I sometimes get stuck on this. You see why, I think, yeah? All right. So, what comes next then? So for z greater than or equal to the modulus of z greater than or equal to r as defined there, hence we have, and here's what he points out, a sub n minus 1 over z plus a sub n minus 2 over z squared plus dot 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 plus a sub 1 over zn minus 1 plus a sub naught over z to the n are less than, he says, modulus of a sub n over 2. And right. So the yeah. Right. There is a step that I haven't written down, which is take this triangle inequality. You have n terms. Each one of those apply the red inequality, and then you have n times a sub n modulus a sub n over 2n, which just gives us 2. Right. So there's a step I didn't write down. All right. And then he says, okay, use this result and the inequality, modulus of z1 plus z2, right, modulus z1 plus z2 is greater than or equal to the modulus of the difference of the modulus of z1 and z2, to show again for z larger than or equal to r that the modulus of a sub n plus a sub n minus 1 over z plus a sub n minus 2 over z squared plus a sub 1 over z to the n minus 1 plus a sub naught over z to the n modulus is greater than modulus of a sub n over 2. So again, I think so. You know, just literally, we're saying this is z1, right? This whole mess is z2. So the modulus of z1 plus z2, right, is greater than or equal to modulus of the modulus of z1 minus the modulus of z2, right? But what is the modulus of z1 equal to? That's modulus of a sub n. And the thing is, we already have above that the modulus of z, I mean, this is the modulus of z2, right? So the modulus of z2 is less than a sub n over 2, which means that is at most what? Does that make sense? I think that actually, this going to there makes sense if you think about it. So we know that the modulus of z2 is at most a naught, the modulus of a naught, excuse me, a sub n over 2. And we're looking at the difference of the modulus of a sub n minus something which is at most a sub n over 2, so that must be greater than, right? Worst case scenario would be the equality, but we can't meet equality of a sub n over 2 because we don't have the modulus of z naught, z sub 2 equal to a sub n over 2 either. Does that make sense? Bethany will not agree to anything today.
I'm like a little bit confused.
Where?
I think the last step,
The last step. Okay, so
like the modulus of a sub n minus the modulus of z2.
we know that this
That makes sense.
is less than that. So I'm subtracting something that is at most half of this.
Oh. Okay.
If you don't understand the blue thing at the bottom, don't worry. This will come to you later. This is okay. Now, what's the next step? The finishing blow, if you will. You just multiply by the modulus of z to the n power, right? And that gives us a sub n z to the n plus a sub n minus 1 z to the n minus 1 a sub 1 z plus a sub naught is greater than I want less than. Oh, I'm freaking. Oh. My homework problem is the opposite, isn't it? I mean, I am not misreading it. It does say that this is greater than a sub n, you know, in other words, we have modulus of z to the n times the modulus of a sub n divided by 2 is less than the modulus of p of z.
Wait, which one is what we want?
I thought I wanted to.
That's what you have that. That's what
Oh yeah, I do think that's what the arguments on the board show. But what I have a sense of dread about is that my homework problem has a typo. Let me see something over there. Not Min, listen, Min. King was like, he's going to have his grading done, and so I can turn it back to you guys on Friday. I was like, oh, great. And then it's not done. And you know what got him? Same thing that got me. That miserable, worthless piece of garbage, problem 37. Oh, that problem. It ate a whole Saturday of my life. And what is that from? I assigned a problem from a textbook. I should learn by now, don't assign problems from textbooks. Whenever I do, there's some kind of dastardly secret hidden inside it that I'm not aware of. Ah, yes, my inequality is the opposite way. So I think we should say, there's a typo in problem 49. We want to say that the modulus of P of Z is greater than the, So with this, we'd have that the modulus of P of Z is greater than, you can throw equals if you want. It may or may not actually be possible. But whatever. Modulus of A sub n over 2, modulus of Z to the n, right? And so in other words, we can think about this thing being the M, right, that I talked about. Application. Suppose you're integrating dz over P of Z over a circle of radius r, half circle. So like from r to minus r. Could you bound that reciprocal then? P of Z is a polynomial of order n. So let's see here. If our f of z is 1 over P of Z, right? And suppose we make r like that. Actually, I don't even want to think about, well, I want to say r is, let me call this r tilde. And let's say that r tilde is larger than r, okay? In the r that we defined earlier here. Then if you look at the modulus of f of z, this is what? Less than what? Right, 1 over, or if I'm being lazy, this, right? But on the circle, that's equal to 1 over m r to the n also. So by the ML theorem, by the ML theorem, this is less than or equal to 2 pi, well, pi r divided by m r to the n.
Is the R over there, that R or R tilde?
Oh, I'm sorry. I need tilde, 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 tilde. Tilde, tilde, tilde. I probably should have put a tilde on the stupid one that I defined in terms of the coefficients here. So, Stacy, while you left, we calculated the integral of 1 over a polynomial over any half circle of radius larger than that bound, and we saw that it was 0. Well, not yet. What happens as r tilde goes to infinity? Right, so this goes to 0 as n goes to infinity, provided what? I shouldn't say as n goes to infinity. I should say as r tilde goes to 0, infinity. Sorry, I'm an idiot. As, what's that? Greater than 1, provided n is greater than 1, yeah. So, I mean, you don't really need the full power of this result for specific examples. For specific examples, you can basically play this game, the blue game down here. On specific examples, you can explicitly construct the bound, which we use then to show that that half circle integral goes to 0. But this is a nice result to know about, that we can always make a polynomial larger than just the leading coefficient divided by 2 times the modulus of z to the n. It's kind of neat. And it is not an easy result to actually carefully establish. I don't know of any non-technical way to get at this, but I also know that there are a lot of examples where having this in our list of things that we know simplifies our life greatly. That's why I've assigned this problem, so that we get this over with. Now we have it to work with if we need it. It is not representative of what we're after at this part in the course, right? I mean, it's kind of an outlier in terms of problems. So let's talk about other problems in that homework set if you guys want. Can I put the screen down? Uh-huh.
Well, you can't figure out which story.
Let's see here. So part D, give a particular choice of alpha for which log sub alpha of 2i agrees with part C. So part C, what was part? Let me draw a picture so I can think through it. What was part C? Part C was
I'm pretty sure it's
from 1 to I, huh?
because it's going in the other direction. That's why.
And 1 to I, and then I to 2i, huh? Is that right? So I'm having you guys go from 1 to I up here to 2i. No, I think it's what it says. It says C. No, I mean this. It starts at 1, it goes to I, goes like that. That's C3. This is C2. That's just that for part C. That's C prime. And so you calculated the integral of dz over z for this C prime, yeah? And what did you get? Oh. Natural log of 2 minus I pi over 2 is what you got.
And in part A, it was that, but plus I pi over 2. So that's why it felt like that.
What's the difference between...
Are we going clockwise in part C?
Oh, thank you. Okay, I knew I'm missing something because I'm looking at A and C and they look the same to me at the moment. You're right. So I drew the picture right now for part A. I was talking about part C though. I should have drawn this picture. Right? Clockwise. Right? Clockwise. From clockwise arc from 1 to I, and then right. Versus, so this is part C, versus part A, which was what I had drawn. Right. So this was my C2, and this was my C. Excuse me, this was my C3, and C prime was C3 union C2, whereas my original C was C1 union C2. And we're supposed to calculate the integral over C of dz over z. Ah. Well, that would definitely, and so you don't agree with what's on the board now? Okay. I don't mind calculating one of these with you guys. Which one would you like me to calculate? C? All right. Let's do it. So the integral over C3 of dz over z, if I just do direct calculation, which is what I'm after here at the moment, is the integral from 0 to, looks like 3 pi over 2 to me, of, minus 3 pi over 2, right? Minus 3 pi over 2 of, well, I e to the it over e to the it, because, you know, we've got z equals to e to the it for 0. Well, I can't do that either. There's a minus here. There's a minus there. There's a minus there. I got to be careful, guys. See, I need a minus it, otherwise it's not a counterclockwise parameterization, right? E to the minus it starts at 0. It starts at 1 when t equals to 0, and it sweeps back around to I when t equals to minus 3 pi over 2, I think. Am I right about that? Not. That's what I'm wondering. That's what I'm wondering. Yeah, and if I put the equation in the limits, I got to do other stuff. Okay, so 3 pi over 2? Just 3 pi over 2? Oh, yes, yes. Sorry. Don't try to do stuff in your head. Write it down. So e to the minus I 3 pi over 2, right, is equal to e to the I pi over 2, which is equal to I. Okay, we're good. I got you guys. So agreed. 0 to 3 pi over 2. And so dz brings down the minus I e to the minus it. And so we're left with minus I, there's a dt, integral of dt from 0 to 3 pi over 2, which I believe would be minus 3 pi I over 2.
For the
because the
What are the rules? Because the reason that we put ECIT in the denominator is because we're using polar coordinates, correct?
the reason, no, you have to find a path for the curve that parameterizes the curve, right? So like C3 is this clockwise section of the unit circle, and e to the minus it is a clockwise parameterization of the unit circle is the thing. Yeah. So I think I get minus 3 pi I over 2. Now that's not the whole thing, right? That's just the circular part of it. We still got to calculate the integral.
So that's the same for part A.
Yeah, that's the same as for part A. But it might be helpful to people to see that. So there, for the vertical part, which I'll put over here, we have z equals to, what would that be? It, 1 less than or equal to t less than or equal to 2, right? So dz is I dt, and the integral of dz over z over c2 would just be the integral from 1 to 2 of I dt over it, which just gives me natural log of 2 minus natural log of 1, which is that natural log of 2 you guys were just telling me about. Woohoo! So it looks like I get log 2 minus 3 pi I over 2. Yeah.
Yeah, that fixes the problem.
That does fix. Okay, good. Well, I guess that's it for you guys. Do you have another? I mean, I think one more question if you got one more. Yep.
For problem 44, is it appropriate to take that figure 8 and just split it into two different simply connected domains?
Well, I mean, I don't know. You could look at it a lot of different ways, I suppose, but
Is it not as easy as it seems?
it's easy. But I mean, here's. So here's my interpretation, guys. So if you just hatch, think about everything like in here. That I wish I had a chalkboard. It's worthless whiteboard. Anyway, so that being D then has the boundary of D is what? It's got like the right part, the left part, right? It's CR union CL, but you got to be careful. Like the CR and the CL I'm talking about are what? They're yeah, the outer ones. The CR would be like that. The CL would be like this, right? And so that's not quite compatible. That's not compatible with the. Oh.
Wait, if you're talking about the boundary of the whole thing, isn't that like in this problem gamma minus gamma 1 minus gamma 2? Or something like that?
Union with minus gamma 1, union with minus gamma 2, right? Yeah. But my point to you is that gamma is not just CR union CL, is it?
I thought gamma was the whole thing.
No, gamma is the outer edge. Gamma is the
Right, the whole outer edge.
whole outer edge, but that is not CL union CR. Because CL union CR, I'm giving the positive orientation as pictured, the clockwise outer orientation. Whereas gamma does not have that. Gamma is opposite. It is, in fact, gamma is like this instead of like that. So gamma is actually like minus CL unioned with, well, CR.
Right. And then it's just the theorem that says that if it's a closed form, then we can continuously deform it and maintain the value of the integral.
We could look at it that way. You could also look at it as it's a closed form, and which means it's holomorphic on this bounded region, right? So this is equal to what? I like the deformation way you're talking about. That's good. But another way to say is that this is equal to 0, which means that the sum of these four pieces works out to 0. But I gave you the integral around gamma 1 and gamma 2. So you could figure out what the integral is around the... but you're right, you could also just deform the left lobe to the...
I just wanted to make sure that it's appropriate to
Yeah.
view that figure 8 as being two distinctly simply connected domains.
That is true. Yes.
Wait, so it's not 0?
It should be 42, I think.
Okay.
That's the answer to everything, so probably.
I knew that, right? I found that out.
Just when you get 42, you feel like, oh, this is right. It could be, yeah, it could be negative 42. I don't know. Could be negative 42. And negative 42 is also possible because I could have been trying to create a problem with the answer is 42. And through my lack of understanding in the creation of the product, I make it minus. Very possible. All right. Well, I'm going to stick a fork in this one. It's done.